All right, guys, welcome to chapter 3.2, second video. We're going to talk about local linearity and implied by differentiability. And this is sort of an interesting idea. Is the basic gist of this is that if a function is differentiable, well, what that says is that the limits from both sides of this point must be equal. And that sort of implies that if I zoom in far enough, at some point I will see equal slopes on both sides of my point. Now, it may require me to zoom in for a while, but they'll be there. So let's take a look at a couple functions. First of all, f of x equals the absolute value of x. Non-differentiable. I got a corner right here. Okay, I've got a corner right here at 0, 0 for the parent function. And no matter how far I zoom in, the slope on this side will be -1. The slope on this side will be +1. No matter how far I zoom in, I have a corner. Well, let's look at a slightly more complicated function. G of x equals square root of x squared plus 0.0001 plus 0.99. If you graph this, and you can pause and dive into your calculator for a second, it looks like this. So the question is, what happens here? This is where relying on the graph becomes a bit of a problem. I said during the last video that, hey, just take a look at the graph. But the reason we were able to take a look at the graph is because we absolutely positively know that the function absolute value of x has a corner. Well, what if we don't absolutely positively know what this graph does? Because we don't. But what I can do is I can zoom. Now, it requires an awful lot of zooming, and what I'm going to recommend is that you pause right now and you either set the zoom points to the bottom of this function, or you do a zoom box around the bottom of this function and do it until something changes. It might take you 7 or 8, 9 zooms, but what you eventually find, and I'll assume that you paused and did this, what you eventually find is that this function, if you zoom in far enough, looks like that. And if you zoom in even further, eventually it looks like that. This is called local linearity. And this is going to be a super short video because all this is a definition, is that local linearity says that if a function is differentiable and you zoom in far enough to the point that you're interested in, it's eventually going to become linear just in that little bit. This is actually sort of useful because we're going to use this way down the road to say, hey, as long as I stay close to that point, I can assume this function is linear. Really, really close to that point, I can assume it's linear. Has some pretty significant ramifications for manufacturing and tolerances. So we'll come back to this later. Be aware of the definition. Local linearity, differentiability implies local linearity.